Welcome back to week 3 of the Development Research in Practice course. If you watch the sessions from week 2, you already know me, but for anyone watching these sessions out of order, which is okay, my name is Kristoffer Bjerkefur and I am a data science consultant at Dime Analytics. This week we'll be covering chapter 3, Establishing a Measurement Framework. Last week, we discussed how to set up your computer and other technical tools to be ready for the data work. The topic of this week is to plan, document, and communicate the data needs needed in the data work. Our experience is, unfortunately, that communication about data needs too often rely on oral tradition where knowledge about the principal investigator's vision for the data work is communicated in a combination of spoken words in meeting or in long series of emails that will not be available to future team members. And then that knowledge is passed along among other team members in other spoken conversation or even more long series of emails. Oral tradition was a great way to pass on legends and mythology in the ancient times. Without that, human culture would be so much less rich. However, oral tradition is not good enough for modern empirical research. The tool that we are suggesting to use instead is to use a data map. During the writing of this book, we introduced the Dime Analytics data map template. Our data map template has 3 components: data linkage table, master data sets, and data flowchart. Version of these components has been used before in Dime, but as a part of writing this book, we stipulate guidelines for each of them so that they fit together and complement each other, and we call that the Dime Analytics data map template. The first section of chapter 3 covers this template. And again, you don't need to use exactly our data map template in your project, but if you do not have a system already for documenting and communicating data needs, metadata about data sets and observations, and how original data will be transformed into analysis datasets, then we strongly recommend that you give the Dime Analytics data map a try. And even if you have a system already, we hope that you still learn something when reading about our template that you find useful that you can add to the system you already have. The second section of chapter 3 gives a brief introduction to different research designs and show how they have different data needs. We introduce the concept of research variables and measurement variables. Measurement variables are variables that says something about the topic of your research question. For example, household income, bias in courtrooms, traffic safety, etc. These are all topics researched at Dime. Research variables, on the other hand, are the variables that link your observations in your data to your research design so you can make evidence-based statements about what, for example, leads to higher household incomes, the difference in bias in a courtroom between 2 groups, or which government program leads to the biggest improvements in traffic safety. What research variables you need depends on the research design you use, and you need to make sure that this is expressed in your data map. This is what section 2 in chapter 3 is covering. Finally, it is common that research designs have a random component. And the third section of chapter 3 covers how to implement random processes in your code reproducibly. To illustrate the importance of this, in the code reviews that Dime Analytics perform on all Dime publications before they're made public, the most common reason why we cannot reproduce results is that a random process was not implemented in such a way that it was reproducible. This leads to result not being reproducible, which we cover in chapter 1 is one of the important pillars in the Dime research standards. In our book, we lay out the steps for reproducible randomization in Stata, but the principles are the same in most other coding languages, but the implementation can vary slightly, so if you do not use Stata, you need to research how this works in your programming language. One of the main advantages with a data map is that it allows the task team leader or the principal investigator to communicate their vision for the data work to the rest of the team, as well as allowing the research assistant to communicate their understanding of that vision back to the principal investigators. Typically, the data map is created by the more junior members in the research team. At least they will spend more time working on it. But it's important that the development of the data map is an iterative process between the head researchers and the junior team members until the data map is an unambiguous documentation of the vision for the data work. This will lead to fewer errors in the data work, which will save time and lead to high quality research. And a data map that is kept up to date will also make any onboarding of future members of the research team much smoother, and it will also reduce the risk of institutional memory loss when someone leaves the team. In most projects, it is the PI that develops the research design of a project. This book only briefly covers this process, as the scope of this book is the practical implementation of the research design during the data work. That is what in practice refers to in the title of the book, Development Research in Practice. This book focuses on the part where the research design is translated into data needs, which is typically done by the PA, and it's typically the research assistant's responsibility to add those data needs to the data map to make sure that those variables will be created or acquired to be later used in the analysis. Finally, creating any research variables tend to be a task for a research assistant, but it's ultimately the PI's responsibility that is done both correctly and reproducibly. These are the required readings for this week. Obviously, we want you to read chapter 3 in our book. We also have listed 5 wiki articles, and they're mostly focused on the data map. You have a general article for the data map, and you have 3 articles for each component of the data map. We also have 1 article about randomization that we want you all to read as well. Finally, we also have some additional suggested readings. For example, if you want to know more about the research designs, especially for impact evaluations, you can read the Appendix C. This is cover a little bit more the process of how to create a research design. But again, this is not the main focus of this book. Other important wiki articles, if you want to read more, is the article about ID variable properties, and you also have clustered sample and treatment assignment and stratified randomization. We also have a training that we link to, which unfortunately doesn't have any recordings, but you can see the slides if you click the link that you see in this slide. Additionally, we have a recommendation here that of a book that we like, that we think is really good. It's a recent book. It's come out earlier this year, 2021. And it covers much more of the theory of different research design, a little bit of the math of it as well. So if that's what you're interested in as well, in addition to the practical implementation of this, which our book covers, we recommend you to read this book. But this is a full book. You absolutely do not need to read this full book for next week as well. I hope you enjoyed the readings for this week, and I look forward to have a discussion with all of you on our lecture session later this week. Thank you very much.